Okay, as I mentioned, we'll talk about Python 3 today, and in particular, I will tell you how to install Python, how to get started with Python. I'll tell you about variables and the data structures that you have available in Python, about control structures like while loops, if statements. I'll tell you about functions in Python. And finally, I give you a glimpse into classes, because that's what we're going to use in the assignment. And I extend a little bit more on classes next time. Let's start with installation. So you can actually install Python various different ways. And if you're lucky, you might actually have Python installed on your system. So for example, on Ubuntu, Linux, that comes by default with the Python installation. Nevertheless, I recommend you to install Python using the Anaconda distribution. So Anaconda is not just a Python installation, but it's an entire distribution that comes with the Python interpreter itself. But it also comes with a package manager. So a package manager allows you to install additional packages into your Python environment, and even a so-called environment manager. It also So Anaconda is not only available on Linux, but it's also on Mac and Windows. So kind of independently where you are, you can use the same, you can get started with the same system. And also Anaconda works on the EFI machines. So there's a section on the web page, in the Obgabe section on the course web page, where it explains to you how to install Anaconda on the EFI machines. So one of the reasons why I like Anaconda over, let's say, a system install is because you can have a local installation. So you can install your Python package with your Python version that you would like and all the dependencies that you would like in a local directory. And then if you decide that you want to switch to a new version, you just delete that directory and install the next one. Right? Or you might even want to have multiple Python versions for different projects, let's say, parallel on your system. And so for that, you just have different Anaconda installations locally on your computer, and you can switch between them. So that's part of the reason why I think these Anaconda distributions are very useful. So a quick guide how to get started with Anaconda. So it's free. You just go to the web page continuum.io and follow the installation instructions. It should be fairly simple. And then when you're done, you can go to the console and type in Python ---- version, and you should see if the installation was successful. You should see something like Python 3.x. It might be 3.5, might be 3.6 or 7. And then continuum analytics. So this is this just indicates that you've installed that you're actually running the Anaconda distribution and in a different Python version. So once you're using this Anaconda environment, you can also install additional packages. So the Python interpreter is actually a very small language, and it might be beautiful and simple, but it's not so useful per se. Python really becomes powerful with all the additional packages that you can install. And so the Anaconda distribution already comes with loads of packages. I think probably, I don't know how many, but most of the common packages are already installed when you installed Anaconda. But sometimes you want to install additional packages. And if you want to do that, you use the Conda package manager. And so there are 3 important commands that you need to know. So if you want to search for a package, let's say you're looking for a package called SciPy that you would like to install. So you can type in conda search SciPy, and then it will list you all the packages that contain the word SciPy. And then you found the right one, and in order to install it, you type in conda install SciPy, and after you've installed it, you can use that package. And then there's a similar command for removing packages again, or upgrading packages, for example. And then at the end, you can also list the packages that you've currently installed. So it's a fairly simple package manager to kind of switch between versions and install new packages that you might want to use. Okay, so one important thing is obviously everyone gets lost at some point, and we need to know how to get help. So how do we get help when we're working with Python? So first of all, as always, there's really, really good online references that you can find. So in many cases, just Googling the particular error message might get you a long way. There's also a bunch of good books and tutorials that you might want to look into. So I've added 3 here. All of them are for free, so you can just follow the links in the course lectures to look at these books. So all of them are Python 3. So there's, maybe I should say 2 words about the Python versions. So essentially nowadays there's Python 2 and Python 3 out. And so I think actually Inf 11.00 teaches Python 2, is that correct? Yeah. So, in a way, Python 2 is dying and should be dying because it's, I think, 10 years old or so. So Python 3 is, at least in the past 2 years, I would say, has really made the shift. And yeah, I think when you start a new project, the default should just be Python 3. So just so that you know that. But there's only very small differences. So actually, quite often, it's very easy to also change a Python 2 program to become a Python 3 program. Anyways, but all these books here, these are Python 3, and yeah, so you can just use them. One thing that's also really useful is that is the built-in documentation that comes in with Python. Let's say you're using, let's say you want to use a module that you're not familiar with, and you just want to learn how to use it, right? So one way is to open up the browser and kind of find the online documentation. But if you're already working in a terminal, then there's a command that allows you to obtain the documentation straight away. And that command is called pydoc. So you can type in pydoc and then the module name, and then you get the documentation of that specific module. You can also type in pydoc module name dot a specific function in that module to get the documentation of that function. So I'll show you an example. So here's, let's say there's this module called sys in Python, and particularly I'm interested in this function called exit that's in there. So I can run this, and here you get the help message. And so in particular, the important part is down here. When you call this function, then the interpreter will be exited. So the program will just stop. Right? And then you might want to look, okay, so what is the return value, which arguments does it take in, and so on and so forth. Okay, let's look at our first Python program. And it's going to be a scientific Hello World program. So this is what a scientific Hello World program looks like. It's got 5 lines or 6 lines of code, and we will dissect it in a second to understand what's going on in each line. The important part is, for now, if you want to run this program, what you need to do is you take this text and store it into a file, for example, hw.py. So the ending doesn't really matter so much, but just to conform to the standard, it's one typically calls Python files such that they end with .py for Python. So we take this text, this source code stored into a text file, and then we can run it. And we can run it very similar to bash scripts, just that we now, instead of using the bash interpreter, we now use the Python interpreter. So we call the Python interpreter, and as the first argument, we provide the script that we want to run. So here our hello world.py program. And then we can also pass in additional arguments, like a number. And then when we run it, we get an output here. So we get, it does some scientific computations here for us. There's an alternative. If you're in Linux or Mac, you can do the same trick as we did for the bash programs. You can make a script executable. So if you take this, if you run this command here, change mod command changes or modifies a file, and in particular it modifies it such it becomes executable. So this is the +x means we're adding the executable flag to that file. And so once we've done this, we don't need to provide the name of the interpreter anymore, but we can just run the program with /helloworld.py and then the argument. So these are the two ways. And if you're in Linux, you can make it executable and run it without the interpreter, or you always just add the interpreter explicitly in there. Both things work. So let's dissect our first program and look what's going on line by line. So the first line was very similar to what we already had in Bash programs. The first line is actually, it's a magic comment. So also in Python, these hash signs are normally comments. But if it's in the first line, and if it has this format here, then it's a magic comment, and it tells the Linux or the Mac system which interpreter should be used if it's not explicitly provided. So here, I'm telling the operating system that I'm running a Python program. In the next two lines, we loaded additional functionality in the Python program that we need. And so in particular, there are two functionalities that we are loading in. The first one is the sinus function that comes in from the math package. So the math package is a package that actually comes that comes with the Python environment. But by default, it's not loaded. So if you just start the Python interpreter, you don't have the sign function available. For that reason, we need to explicitly say load from the maths module, import the sinus function. So after this line, we have the sinus function available, and we can use it. In the same way, we import the sys module, and that provides us, that loads in the sys module and provides us with all the functionality that the sys module gives us. In particular, we looked already in this sys.exit function, right, that we can use to exit in the program at a specific point. And so after we loaded in the sys module here, we could, for example, access the exit function. So in the next line, what we're doing is we are reading in the first command line argument that is provided by the user. So remember what our script did. If you go up here again, our script took in a command line here as a number, and then as the output of the script, it tells us what the sinus of that number is. So it tells us the sinus of 0.8 is this number down here, right? So in order to write this program, we need to get access to this command line argument up here that was provided. This is what's happening in this line here. And it's actually the sys module that provides us with the command line arguments. So by typing in sys.argv1, we get the first command line argument that the user provided. And these are typically strings. And so because we know that this first command line argument is a number, we explicitly convert it into a floating point number. This is what this part here does. And then we store the result in a variable called x. So at this point, x is a floating point number and that we can use to, that we will, in the next step, apply the sinus function to. So note here that we haven't declared the Python variable x here. So in Python, you don't need to declare variables. We don't need to say float x. We don't need to tell Python that x is a float variable. It implicitly gets it from what we assign it to. So here's the next, and that's actually the last line of our code. So here we print out the output that we want to see on the screen. So we use the print function. The print function prints out strings, not surprisingly. So the print function takes one argument here, which is all the way down here. And this is a string, and it's a formatted string. in particular. So you can see these quotation marks here, they indicate a string, and then you just have some normal characters. But then you have these curly brackets here. These curly brackets, they are placeholders. So whenever you have a curly bracket, you can actually insert the value of variables into that placeholder. And so you can see there's a second placeholder down here. And now the question is just, what do we want to insert there? Well, for the first one here, we just want to insert the value of x. And in the second one, we want to insert the value of sinus x. So the reason why we can use sinus here is because we've imported it before. Okay, so that's hopefully fairly straightforward. So by default, when you do this formatting of strings, Python will, let's say you've input a number in here, right? So there's actually, it's not clear how this number should be formatted. Right? So the sinus of 0.8 has many, many digits, and the question is, shall we only show kind of the first 3 or the first 5? Python just comes up with the default way of visualizing that number, but you can also take control and explicitly say how this number should be visualized. So this is actually done using the C style, the C formatting style of the printf function. So C, this is kind of standard in the C language on how to format strings, and Python adopted that. So here, for example, this notation down here tells us to have 3 digits after the comma. So this is, for example, how this number would be formatted. But there's various different choices that you can use. Okay, so that was our first Python program. Okay, so are there any questions so far? No. Okay, good. So let's see what else we can do with Python. So one thing that I actually do quite often is I just type in the command Python, and then I get what I get on the screen is the Python interpreter, and you can immediately use it as a calculator. So for example, you can type in, you can add 2 numbers together, 1 plus 2, you get 3. You can divide numbers. You can use brackets to make sure that you add things up in the right way. You can also compute the power of numbers. The notation for that is the double asterisk. So that differs a little bit between languages. So in some languages, it's maybe like this, or maybe other languages have something like this. But in Python, you'd use this double star to indicate a power. So also, you can work with complex numbers. So if you're a fan of complex numbers, then you can indicate. So whenever you use the J symbol, that is the imaginary part of the complex number. So you can construct complex numbers just by having a real part plus an imaginary part. And then you can, for example, multiply them and you get the result out there. So if you want to do more complex calculations and you want to use a function that is not immediately available in the language, then we need to import the relevant functionality. And so most of what you will need is in the math module. So let's say you're interested in the logarithm of basis 10, and you want to use that function. So then if you look into the math module, look at the documentation, you'll find that there's a function called log10. So then we can just import that function and use it afterwards. Okay, so that was kind of the basics of how to use Python as a calculator. So now let's look into the different data types, more complex data types that we can use in Python. So as a start, let's have a closer look at strings. So strings in Python you can express either as a single quote or as a double quote, as shown here. And there's actually no difference between the two. So you can choose one over the other, whatever you prefer. You can also use multi-line strings by using triple quotes. So when you want to have a string that goes over multiple lines, just start with a triple quote, then copy and paste your text or add your text that you want to have, and then end again with a triple quote line. One thing that you need to be aware of is special characters in strings. So they might, these you need to treat in a special way. So in particular, the very common ones are if you want to use backslash in your string, or if you want to use the quotation mark or the double quotation mark in the string. So it's not surprising that if you indicate your string with single quotation marks and you start using single quotation marks in the string, then Python will think that your string will stop early, right? And then you will end up with problems. So in order to indicate that you have a double quotation mark in the string and you're not indicating that the string actually stops, you just add the backslash. So here, backslash double quotation mark tells Python to, okay, I'm actually talking about the double quotation mark in the string. I don't want to end my string yet. So this is how it works. And so also if you want to use, so the problem is if you make the backslash special to indicate a special character, then the backslash itself becomes a special character. So if you want to use the backslash as in a string, then you need to use a double backslash. So here's an example for a string that contains quotation marks and it contains a backslash. Right? And this is how you would represent it in Python. So then we can glue together strings, which is often very useful. And it's a bit surprising at first, but we actually use the normal mathematical notation to glue strings together. So for example, if you take a string and multiply it by 3, then what will happen is that actually that string is multiplied 3 times. So in this case here, you get 3 times 3 hello, hello, hello. And then you can add the string world, and then you get a world at the end. So here by saying hello times 3 plus world will give you hello, hello, hello world. So this also, for example, that might be a bit surprising first, but if you do 1 times 100, right, you don't get 100, and you get 100 times the 1, just so that you're aware of that. If you really wanted to compute 1 times 100, or let's say 2 times 100, you would need to take that string, convert it into float, or an integer, let's say, and then multiply it by 100. Then you would do the mathematical operation again. Okay, so the same operations here with gluing together and concatenating strings also works when you have variables. Let's say you have a quote and you want to print out that quote comma separated 10 times. Right? The way I would do that is you take the quote, add the comma, and then print out the result 10 times, and then add the quote again at the very end without a comma. Okay, so it works exactly the same as above, just with variables. So slicing is a very, very important concept in Python, and you'll see that this slicing is not just important for strings, but we'll use it over and over again later for the other data structures. So slicing just means that if you have an object like a string, and you want to access a slice of it, starting at some point and ending at another point. So for strings in particular, we're just talking about substrings. If you have a long string and you're interested in getting a substring of it, the way you would do it is by slicing. And this index, the notation for slicing are these these square brackets where you provide two arguments. The first one is where you want to start the slice, and the other one where you want to end the slice. So for example, if you want to take our quote and we're interested in the slice starting from the second character all the way to the sixth character, that's how you would do it. And then you get the word will out. You can also leave out one of the arguments, so either the start or the end argument. And if you leave it out, Python will just substitute it with, if you leave out the starting argument, then Python will just start from the first character. And you leave out the end argument, then Python will just go all the way to the last character in that string. So for example, if you're interested in the quote, in the first 6 characters of the quote, rather the first 5, then you just leave out the first argument and provide the index, the position 6 at the end. The same way, if you're interested in the quote starting from position 6 all the way at position 7 all the way to the end, this is how you would do it. Right? So you can really kind of slice up your string and get the components of it. And then finally, you can also use negative indexing to start the indexing from the right rather than from the left. So normally, our indexing starts at 0 from all the way to from the first character, right? But if you're using negative indices, then you're actually starting from the last character going backwards. So this is indicated here, visualized here for the word chips. So let's say we have, actually I should hide this and ask you. So here we have the word chips, and we're interested from character position number 1, right, which is here, all the way to character position -2, which is going backwards. 0, -1, -2 is here, right? So essentially, going from 1 to -2 gives us these two guys here, right? And so if I execute that, that's exactly what we see. So this is just how you should kind of keep in mind these indexing notations, and you can use negative and positive indices. One important thing that you need to keep in mind is, so one important distinction when we talk about Python data structures is that some of them can be changed and other ones cannot be changed. And so strings, and when they can be changed, we call them mutable. And if they're unchangeable, then we call them immutable. So Python strings is an example of an unmutable data structure, which means that we can't change them. So for example, if I try to take the quote, I get the first character of that quote, and I try to change it to the character X. Okay, so this command is an attempt to change into a string, but if I execute it, I get a type error, and it tells me the string object does not support item assignment. Okay, so this is it's just a consequence of the fact that we can't change strings. Now, obviously, sometimes it would be nice to, given a string, you want to do some operations and get another string, or get a changed string out of that. So the only way you can do that is by creating a new string. So for example, let's say you want to have our quote, but somewhere now in between, we want to add this character X. So the way we do that is we use our slicing notation, right? So we take the quote all the way before that character, then we add the character X, and then we add the rest of the quote again. And then we store, so this will generate a new string now. It's a new string, and we store that in the same variable name, and we can print it out afterwards. Right? So the important point here is that we didn't really change that string, even though we're using the same variable name. We really created a new string and stored it in the same variable. So here's a kind of a cheat sheet of useful string operations. Let me zoom in a little bit. So I won't go through these in all detail, but I just thought it might be nice to have them on the slide so that you can look them up if you want. So just some examples. One thing that I often use is, for example, this one up here. This is a test to check if a substring is contained in a string. Let's say you want to test if the word day is in quote, and then typically use it in an if statement, right? So that's what you would do. You would use the in keyword. Another one that I use a lot is this split statement here. So let's say you're reading in a string from a file and you want to split it up on the semicolons, let's say on a comma or a new line or whatever, or at white spaces here. Then split is the command that you're looking for. It splits up the string into many components. By default, it's a white space, but you can actually provide another character here if you would like. And then what else is useful? Lowercase is uppercase, convert to lowercase, convert to uppercase, and then strip out white spaces or new lines at the end and the beginning. That's also often quite useful. So remember that because strings are immutable, many of these functions here, they don't actually, none of them change the string, right? They often just return new strings. So let's say you're calling quote.lower, this will not change the original string, but rather it will return a new string that is now lowercased. Another very, very common data structure in Python are lists. And lists allow you to group together values. So for example, if you want to have a list containing 3 strings, you would instantiate them like this. So there's the square brackets that indicate if you want to create a list in Python. So you have the square bracket, then you have the first item in the list. In this case, it's a string. Then you have a comma. Then you have the second item of the string of that list, another comma, and then a final item of that list. So here, we created a list with 3 strings. In principle, lists don't need to have the same types. So you can there's no problem creating a list that contains a string, an integer, and a Boolean variable. Right? So you can mix different types in Python lists. Oops. So now comes the part where you see the similarities between lists and strings, because many of the operations that we are familiar with strings, we can also use for lists. For example, if you want to get the first item in the list, we just write my list square bracket 0, my list. That gives us the string hello. Right? If you did the same thing for string, you would first get the first character of that string. Right? For a list, you get the first item of the list. So what I'm trying to say is basically Python considers a string is just a list of characters in Python. Yeah. So then the same syntax, the slicing syntax that I showed you also works for lists. So you can, if you're interested in a sublist starting from index 1 all the way to the end, you type in my list square bracket 1 colon and just leave out the second argument to get all the way to the end. And then finally, our fancy addition and multiplication operations also work on lists. So let's say I want to have the list, and then I want to add 3 new items that contain the character quotation mark, right? Then I take the list and add 3 times a list that just contains 1 item with the quotation mark. And then you get a new list that now contains 6 items. Okay? So there's one big important difference between strings and lists in that lists are mutable. So remember strings we couldn't change. They were immutable. Lists are mutable and therefore can be changed. So the syntax that didn't work on strings, namely here where we changed the value of the third item, now suddenly starts working. So we create a list with 3 items, and then we take the second item and we change it. So we assign a new value to it. And then if we execute it, you'll see we change it from 11, 12, 14 to 11, 12, 13. Right? So here's where the difference becomes apparent. We can not only just change existing items in a list, but we can also add or remove additional items to dynamically to a list. And so for that, we use the keyword append. So we just take the list, call append on it, and provide the new value that we want to have added on that list. So after doing that, we have another entry in our list here, the number 14. All right. So here's the cheat sheet for Python lists. It's a bit longer, but contains many of the same functions that we also know from strings. So one thing that is new is this append, but we can also use negative indexing for lists. Deleting items from a list is done with the del command. So you write del A3 that removes the item at index 3. You can also test if an item is in a list. So let's say you're interested if a specific string is contained as an item in that string, right? In that list, use the same in keyword here. You can check how many elements does the list have. Use len of the list, which is quite useful. You can sum up all elements in a list. You can sort them. You can reverse sort them. Yeah, and so on and so forth. So this is just as a cheat sheet for if you want to look up operations. Okay, next one is tuples. So tuples are very, very similar to lists in that they also, so tuples also stores a number of items. The only difference between lists and tuples is tuples are immutable, so they can't be changed, while lists can be changed. Okay, so that's the main difference. So when you create tuples, instead of using a curly bracket, you now use a round bracket. And in fact, so here in this example, we create a tuple with 1, 2, 3, 4 elements, and again we can mix different data types. So we can have strings, floats, and integers here, for example. So there's actually even a shorter notation for tuples. You don't actually need the brackets at all. You can just say my tuple equal, and then use a comma-separated list of floats and objects in Python, and that will automatically create a tuple. Okay, so this is something that looks unfamiliar at first, but it's might looks a bit surprising at first, but it's actually really useful. And I'll show some examples. One example later on, where this is used very often. So again, since tuples are immutable, if we want to change them, let's say we want to change the second item in that tuple, then we get an error. Then we would get an error message. So yeah, the same trick. So if let's say we really wanted to change the tuple, then what we need to do is one way how you could do that is you take the tuple, convert it into a list, so every tuple can be converted to a list because they're so similar. So you just write list of my tuple, then you have a list. Lists are mutable, so now you can start changing the list, appending new objects and so on. And at the very end, you just converted the list back to a tuple and make it immutable again. So this conversion, again, keep in mind that the conversion isn't, you're creating a new tuple object that has the same items, right? So you're not changing the list to a tuple, but really you're creating a new tuple item with this tuple object with the same items. Okay, it's 11. Shall we have a 15-minute break? We start at 11:15 again.